I'm going to talk about Android Studio and things around Android Studio and some developer experience in Android Studio. We see enough talks about getting your apps better. The apps are only as good as the developer experience, right? So we'll see some of that. Let's start. So my name is Kartik. I'm an Android engineer, and I work at Bilue. And I work with a few clients in the past few years. Next up, I'm going to have a few images come up on the slides, and just quick show of hands if you recognize any of those brands. If you don't, let me know and I'll tell you which brand it is. So let's see which clients have been the most famous and which haven't been. All right, first up, the most recent project I'm working on is this. People who didn't raise their hands, that's Qantas, the premier airline of Australia. Before that was this. I know a few people in this room know exactly what this is because they're working on the same project right now. People who are not in Bilue, they as well. That's NIB, the insurance app, and I've been working with them, was working with them until recently on their Android app project. Before that, it was this. You know this? Yeah, quite a lot of people know this. This is ABC. I was specifically working on ABC News. And if you've seen that stories kind of thing in the ABC News app, the non-composed version of that was built by me with accessibility. I think it's moved to completely composed now, but I'm not sure. This one is a bit tricky. Oh, yeah, of course you guys know. This is AMP, the bank. Yeah, before ABC, I was helping them improve their app. What's next? Oh, this is going to be tricky. Oh, of course. One person I've worked with before, he knows what it is. Right. The next two are related to this one, so you might be able to recognize the next two and then maybe guess what this one is. Yeah, so that was Stream Motion, which is the parent company behind Kayo and Binge apps, and more lately Flash. And I think there's a fourth one as well. I can't remember the name. But yeah, I was off the project soon after Binge was launched. So I worked with so many of the clients, and they've all had different ways of managing dependencies and managing or the state of dependencies in their project. Especially the bigger clients like Qantas and StreamMotion, because they use similar dependencies across multiple projects. They want to keep things very consistent and very tight because they've got security policies and whatnot. This has culminated in this presentation, which I'm giving for the very first time anywhere. So you're all guinea pigs for me, thank you. And so I've got a bit to say about the state of dependency management then. What is exactly dependency management? So software projects rarely work in isolation, right? They always need some extra code or some extra library to be used. You need to be able to organize this. And dependency management essentially is the process where you kind of automate the technique of declaring these dependencies, resolving the actual artifact, and actually ending up using the functionality that is offered by this dependency. It can be complex, and with the addition of open source software, which is probably not always the most standardized software, but gives you great benefits as a developer, it makes it even harder for you to manage the dependency. It's really important. This is all jargon, by the way, so if you sleep, that's fine. I'm going to get to the real code later. You need to consider the security of the dependency that you're including. If a library has a vulnerability and you don't actually foresee it, you end up passing it on to your clients or your users, which is bad. Most of the time, the gain is performance or performance improvements of your software project. So you might miss out on something if you try to reinvent the wheel. So if there's something already there which has performance improvements, why not use that? You obviously want to give a good quality product to your user or your stakeholders. And some libraries, some external dependencies help you achieve that quality assurance as well. And then finally, licensing. All these dependencies, especially the open source ones, come with various kinds of libraries, and you need to consider the implications and the consequences of including those projects in your own project, and then see in unison how it works out well for your project. There are challenges with dependency management, mostly because of conflicting dependencies. You're using dependency A and then you're using dependency B. Both of them have transitive dependency on something called C. Now, there could be conflicts because they're using different versions of C. They're using the exact same version, but your build process is not able to choose which one should I go for. So these challenges are considered when you're doing dependency management. Not every developer, not every software engineer out there knows Semver, or they're really bad at versioning their dependencies. They just push to Git or GitHub and hope it just works out. So versioning also creates issues and challenges when it comes to dependency management. Quite often times you'll see that a certain library targets a staging environment or a not so production environment and offers certain different files to be used there, and then completely different package or completely different artifact for a production one. And sometimes that's useful, sometimes that's creating more challenges for us to manage dependencies. Some best practices. You want to consider compatibility, licensing, and the maintenance and versioning of it. If a library is not compatible with the project that you have in mind, why bother using it, right? If it's not been maintained and versioned properly in the past, and there's been reported issues with that library, just ignore it. Something's not right with it. Breadth of use is an important one. You want to be able to see that it's being widely used by other developers, which gives you confidence that, yes, this is important for us. Ease of integration. Are you going to spend the next 3 days trying to figure out how to use it? What's the point then? The whole point was for you to not spend those 3 days and rewrite all of that code. So that makes it, that's an important thing. Again, the size, oh yes, of course. You don't want to ship 500 MB of dependency for an app, which is just 10 MB, right? So if something's bloaty, you don't want to ship that. And of course, speed and efficiency. If your code is efficient, but the library isn't, then the slowest part of the entire code would be the library, slowing down your entire product. Last bit of jargon, I promise. Strategies when it comes to dependency management. Centralized. So you declare a list of dependencies somewhere, and then each project in your organization or the teams within the organization can refer to that central list and make use of those dependencies. There's decentralized, where you empower each team in an organization or squads in a team, within a team, to declare their own dependencies as they see fit. But that has scalability issues. What if there are conflicting dependencies and they want to, there are cross-functioning teams, and then there's issues with, oh, I'm using version 1, you're using version 2, how do we resolve this? All that nonsense. And then finally, and probably the most useful one, is hybrid. You do have a list of central one, but you also empower the teams to declare their own ones, which kind of override the existing ones. So you still have this base where they set up the dependencies. And then based on the use case, you're like, maybe version 3 solves my problem better than version 2. So I'm going to use this in this project, but the other teams can keep on using version 2. Let's jump into dependency management in Android Studio. As an Android developer, you know, you use Gradle for building your apps and for dependency management as well. Gradle has a few different ways of managing dependencies, and I'm going to talk about 3 of those over here. And we'll see some pros and cons and some metrics as well, and finally a demo as well. Yeah, so by the end of this presentation, you will have some knowledge of how these work, some idea of how to migrate to these different dependency management strategies, and then maybe able to make a decision with your team what works best. I'm not giving that this is the best one, just giving you an idea of what's there in the wild. So yeah, Android Studio uses the Gradle build system. Gradle makes it easy enough for you to add any dependency. Yeah, and what Gradle does is, on the first fetch, if it's a network-based library, it fetches it from the repository and stores it in the local Gradle cache, right? So the next time you're trying to build something and the dependency exists in the cache already, it reuses it, saving you some build time. The few methods that are available as of today, you can obviously declare them completely manually in a hard-coded way, and it looks like this, and tends to get really ugly. It's difficult to manage, especially when you've got multi-modules. You're repeating the same dependency again and again and again, and that increases the chance of human error where you forgot to update it in that one particular module of the 50, and now you're just scratching your head, why is it not working? But if you've got something nice, something small, which won't really need maintenance in the long run, this might just work out. Why waste all that engineering effort in getting a proper dependency management when you've just got two and you're not going to touch it for the next 2 years? Pros and cons already covered. Okay. Yeah, like I said, difficult to manage. There's a lot of duplication in code when you hard code it this way. And there's very limited flexibility in terms of how you can scale it up, how you would want to assign a different dependency for a completely different variant of your software. This one's called build source. It's somewhat of a special module within the Gradle build system. You don't have to add it as an extra module in your settings file or whatever. If there's a presence of build source directory with the right structure in it, Gradle will automatically recognize it. And then you can use that module to define your build logic and constants like this, and some more constants like this. So in the second piece of code over here, this is basically declaring that I have a library which uses the version as defined in the constant above. So you've got granular control over the version itself, and then the artifact also. And then when it comes to actually implementing it in your Gradle file, you just have to call the object. Now, this is good because build source project, or the build source module, it is integrated with Android Studio very well. You've got code completion, IntelliSense, and all those nice things that Android Studio offers. But it also offers separation of build logic. You can write rules and some plugins or whatever and place them in build source, so that's separate to the rest of your project itself. It improves your experience overall that, yeah, I have achieved some sort of separation, right? And then there's reusability across modules. So if you've got 50 modules, each of them can refer to the same build source declaration. And let's say you want to upgrade it, you just upgrade it in one place and it starts working everywhere. But this method also comes with a lot of cons. Build source is a full module in itself, which compiles before any other module or any library or app module in your project. So it comes with overheads. It's got its own configurations, its own build.gradle file, its own dependencies, if any, which means it compiles first and the output gets added to your build script, and then the rest of your modules get compiled. If you're not careful about it, it is possible that build source is the slowest module in your entire project, which means it's going to drag your entire project to slowness. Any small change in any part of build source invalidates most of the caches, and then you have to kind of rebuild your entire project. Gradle sync often doesn't just work. It still uses the old one, so you have to actually build all of it for the updates to take place. And then in terms of scalability, it's only within a project. You cannot share this between projects easily. There are ways, but then it's not part of Android Studio itself. It's more got to do with how Git and any other version controlling system works. And the third one is version catalog. I know a lot of Android developers are very psyched about this. It's relatively new, not so new, but relatively new in Android Studio. It's a list of dependencies, which is represented as coordinates. And then a developer can pick and choose from that list and keep on using it as they see fit. A standard version catalog has 4 sections: versions, libraries, bundles, and plugins. For the sake of the example in the slides, I'm only going to use versions and libraries. But when I come to the demo of 4 of them, I can show you all 4 of them. So yeah, this is how you would define a version. So that variable my spectacular library version gets the value 1.2.3. And then in the library section, I granularly define my spectacular library. So I've got the group there and the name of the artifact. And then the version reference goes back to that particular variable. Now, this representation is called TOML, or Tom's Obvious Minimal Language. However, you can define a version catalog in your settings.gradle as well. It's a bit more painful to define it over there because now you have to create all these individual sections, which the names are predefined. It's just that you've got to do a bit more work for this. So it's just easier if you go this route. And as of today, the stable beta as well as the alpha Android studios, if you start a new project there, this is the default implementation along with the Kotlin DSL for Gradle. So if you're starting a new project, you don't have to do a lot of effort into migrating this. And migration is one of the cons. I'm going to touch up on it. Once your TOML is synced, you don't have to build it from source. A simple Gradle sync works. Your libs.my.spectacular is now available. Now notice that over here, I've got my dash spectacular under libraries, but over here I've got dot. So what Gradle does is any kind of, there are three different kinds of known separators within the TOML file, dash being the most common one, where you can use dot or underscore as well. They all get converted into a dot-based reference later on. So that's why if I had just written my spectacular without a dash, this would change to libs.myspectacular. But because I've got a dash there, I can group them together if I want, logically, not physically, and make my life easy. Pros. It's got amazing integration with Android Studio, got all the code completion. You can command click, control click, and actually go to the actual code where you've declared it. And it doesn't live inside the project. I mean, it can, but it can live outside as well, which means you get to share it with the rest of your team, rest of your organization, without having to use the power of Git. You can declare it centrally, fetch it at build time over internet, or you can have a monorepo of sorts where there's a build folder and then individual Gradle projects inside it, and you can fetch it from there. So it makes it easy to share the dependencies across projects. And it's much faster in performance because it doesn't have that build source compilation overhead anymore. There's nothing to be compiled here. It's just a bunch of code getting referenced into another bunch of code. And there are two cons which I could think of, and these are both just one-time issues. If you're converting from something existing to this, there's a lot of copy paste. So it can get boring and repetitive, especially if you've got a long list of dependency. But then once you're done, it's done. You don't have to worry about it again. And because it's relatively new, not a lot of devs know about it. You all know about it now, so you can now do the upskilling. But again, it's just one-off event. Once that's done, it's done. You don't have to worry about teaching them again because it's so simple to implement. All right, my slides say I have to do some demos now. What I'll do is I'll share my Android Studio. All right. Right. The infamous hard-coded way of declaring dependencies. Just wait while it's syncing. On Android Studio. Right, just ignore the red lines for now. It does that sometimes because I'm running the Iguana Alpha 7. It just came out yesterday. Right, so this is how you would declare everything. It's all hard-coded. Everything is here. The dependencies are all hard-coded. I've just got one module here, but if you have multiple modules, you can imagine how tricky it gets having these same implementations everywhere again and again and again. And these days, Android Studio, the entire IntelliJ platform in general has gotten smarter to tell you there's duplication, please fix it. It's not good. Let's do a quick build scan and see how much time it takes to build it. So I've got this tiny script here. Benchmark. Come on. Thank you. There you go. Thank you so much. Does nothing special. It just cleans the Gradle project and then reruns all the tasks while profiling it and compiling it. So if you run it now, you do Windows terminal. Right, it's compiling, it's doing things, it's executing. And what I'm going to do is I'm going to input the values from the profile output into a spreadsheet, and we'll compare how everything performs. So the hard-coded one took 7.563 seconds. So 7.563. Let's put it here. All right. So this is how it was. I'm going to switch branch to the build source one. I'm going to sync it, but I have a feeling it's still going to complain about everything. So I'll have to build it. Yeah, still complaining, which is fine. If I run the app right now, I know it'll run fine. Anyway, so what I have here now is inside this build source module on the left, I've got my libraries and versions declared like this. So as I shown in the slides, you can declare your constant version numbers over here. And then in the libraries, you can use them like this, just reference the version number respective to this one. And the good thing is, if the library is part of some group, I'm over here, I'm using the compose bills of material, but let's say you were not using bills of material, but all these libraries share the same version number because they get deployed together. You can just keep on referencing the same version number. You don't have to write the new version number again and again. That's just how Kotlin works. And I've got some Android config specific constants as well. Like I can declare my compile SDKs, I can declare my namespace, my Kotlin compiler extensions, all of that over here. And then it gets built and gets added to your build script. So it's all available in your build.gradle over here. Yeah, so I've got the namespace declared like this. Yeah, it's slowly learning that things are fine. See, it's getting colored properly. I can put the build, I put the build tools here, min SDK, target SDK. I can take some pane out and move all these constants into those files again, and all of that will be available. And then the implementation of libraries, just a simple reference to the constant that you've declared. And the good thing is, if I command click one of these, it takes me there. It takes me the exact spot where I've declared it. So I don't have to scratch my head. I don't have to waste hours figuring out where have I declared this dependency, which is not performing properly. Okay, now, why does the terminal keep closing? Let's do a benchmark on this now. Results are available. says 5.64. So we saved some time by adding some build overheads. Great. 5.654. Let's put it over here. Build source 5.654. How do I turn off round off? Number? Yep. Perfect. Thank you, Katie. Okay. So we've got the nice numbers now, which is good. Actually, I'm going to zoom in as well. It's much clearer. Okay. Now, next one is version catalog. Now, the build source directory is completely gone from this one. Whatever I have declared is in version catalogs, and I'm going to reference all values so far I've referenced from build source this time, but from version catalogs. Now, your file for the version catalog sits inside the Gradle folder as the default name is libs.versions.toml. There's no point reinventing the wheel or figuring out why you would want to name it anything else. Just go with the standard and everything should be nice. Yeah, so I've got the same dependencies, same version numbers declared here. Got the compile SDK and everything over here. The library references, including the bits of material. If you notice in the individual libraries from that BOM, I don't really have any version reference. That's because BOM is going to provide me that library. So I don't have to specify a version. If I do specify it, it's going to override what the BOM is providing. The other two sections, which I didn't discuss earlier, they're called bundles and plugins. I can bundle number of, it's not moving. I can bundle a number of libraries together, and then you can just call the implementation on that bundle instead of individual libraries. So it saves some lines of code. Not extremely beneficial here, but maybe in a larger project. And then it also supports declaring plugins over here. You can do that in build source as well, but this one is just right here. In build source, you have to do some special work to get that running. For some reason, the plugin scope doesn't recognize any of these objects. Anyway, so I've got the plugins also declared over here with proper version referencing from the list of versions over here at the top. Now going back to build.gradle, this is the root project one. Now I can just use libs.plugins and then the plugin name and make a decision on applying this or not. And I don't have to worry about versions or anything because it's already declared over there. If I take the module level thing, same thing, except you have to wrap it around an alias call. I'm not sure why, I haven't researched enough, but this is what you have to do. Some of the things which are not dependencies, just constants, so by default, your libs.versions.namespace is a provider. It's not the actual definition. So you have to call get on it on the provider to get the actual values over here. But when it comes to the dependencies block, you don't have to worry about calling the get on provider. That block already knows how to do that. So libs.kotlin.standard library, libs android xcode ktx. Where did my bundle go? Android X compose. Oh, there you go. Libs, bundles, Android X compose. Now I don't have to declare each one of them separately. It's all part of the bundle, declared, done. Okay, let's run the benchmark on this one quickly. That was quick. 3.66. Okay, and just for a baseline, I'm going to switch back to my main branch. And run a benchmark on that. The base branch also uses build source, but slightly differently. It doesn't use a lot of features that I would want to, or things that I've explained here. So it's not a great implementation. So I'm just making that as a reference. 4.61. Okay, going back to slides and refresh. Right, there you go. So we've got the updated values. As you can see, the hard-coded one is the slowest. Okay, maybe my calculations are a bit off, but you get the point. Just consider this column. Ignore these two columns. Hard-coded is the slowest. Build source is slower. Faster, but not very fast. And version catalog is the fastest. They're doing exactly the same thing, referencing the exact same dependencies, except in different ways. So version catalog can actually, in a bigger project, can actually make a huge lot of difference over here. Some tips for dependency management, quick ones. You need to identify, you need to assess and prioritize your dependencies based on what you need. You need to get rid of dependencies that you don't really need or they're bad or whatever. So something more important obviously needs more attention. Try to automate as much as possible. Libs, the TOML file is automating a lot of things for us, referencing and all these things. So make use of it. Make sure your life as a developer is easier so you can focus on solving harder problems in the project itself. Within the organization, establish policies on when you want to update a dependency. How do you review these dependencies? Like obviously, if there's a massive problem that has been fixed, you would want to get that in first. But if something is just introducing a good to have feature, is that important? So all policies around these within an organization are super helpful to avoid any kind of conflicts within the team. As a quick bonus content, dependency updates are important. So in my recent project, what I've done is once I've set up a cron job on my CI server, which once a month uses this Gradle versions plugin by Ben Mains. Determines which dependencies need an update, which ones are up to date. This plugin is very customizable. You can fine tune stuff in it. It gives you a formatted report in HTML, plain text, JSON, XML, or a mix of everything. And all you have to do is just run this task once your plugin is imported. So yeah, my cron job on the 28th of every month runs this and gives me a nice HTML report, which I can use to update my dependencies. All right, what's next? Just 2 minutes, sorry. You can go beyond this and start sharing complex build logic using Kotlin convention plugins or Gradle precompiled scripts. However, these are very powerful and very complex in themselves, and they probably require, at least in my opinion, they require a session in themselves. So I'm not going to talk about it right now, but you can look them up. And that's it. Thank you.